Hi friends, welcome to all. In this video, we are going to solve this packet tracer activity, troubleshoot static and default routes. Before coming to this activity, friends, if you like to get any CCNA version 7 online classes or any project support or any technical support, you can contact our team using our website. Link you will get from the description below. And if you like to get this type of technical videos in future, consider subscribing. And also don't forget to enable that bell icon near to the subscribe button so that you will get notification message whenever we upload a new video. Coming back to this activity, here we can see our addressing table, devices, interfaces, and their IP addresses. They specified IPv4 as well as IPv6 addresses here. Coming to the objectives, in this activity we will troubleshoot static and default routes and repair any errors that you find. Troubleshoot IPv4 static routes, troubleshoot IPv4 default routes, troubleshoot IPv6 static routes, then configure IPv4 static routes, configure IPv6 default routes, and configure IPv6 static routes. So okay, in this activity just we will troubleshoot, just we will identify the problems, then we will troubleshoot it. Coming to the background, a newly hired network technician is attempting to pre-configure a symbol topology that will be delivered to a customer. The technician has not been able to establish connectivity between the three LANs. You have been asked to troubleshoot the topology and verify connectivity between the host on the three LANs over IPv4 and IPv6. We will see the instructions. Step 1. Allocate and document the problems. Record your findings in a table like the one below. So we have to find the problem, then we have to write its solution. That's fine. We will identify the problems first. Here we will be having either static or default route problems in this network. So just we will go through each router, that is R1, R2 and R3. Then we will check the configuration they have done. First of all, we will go to R1. Enable, let me verify, show IP route. And here we can see they configured this static default route via 172.31.1.195. So here they specified this next hop address. We will verify this next hop address. Also, let me check with IP, show IPv6 route. We can see they configured these static routes. Okay, so we will start with IPv4. Coming to the topology here, in this R1 they configured the default route towards this side, towards R2, and here they specify the next hop address, that is the IP address of this interface, serial 000 in this router R2. So just I will go to R2, and here we can see its address 172.31.1.193. Oh, here we can see they configured incorrectly here. They given the next hop address incorrectly, 172.31.1.195. Let me verify it here. And addressing table, we can see it should be 172.31.1.193, but they configured as 195. Yes, we identified the first problem in R1. We have seen this IPv4 default route. Its next hop address they configured incorrectly. We have to correct it. So you can write that problem here. Okay, and solution is obviously we have to remove that IP default route, and we have to add the default route with the correct next hop address, right? We will go back to R1 and here I will give show running config, and we can copy that line, whatever they configured incorrectly. Yeah, it's here. Just I will copy this command because we have to remove it, right? Then conft, then we will give no, and then we will give that command ip root, then this next to hop address. Now we have to correct it. We have to remove this no, then ip root, okay, and here we have to change it to let me once more verify in this addressing table as 1.193. Here I have to give 1.193. okay, so we can verify it. Just exit, show ip root. Now it's correct. Even we have to verify IPv6 also. Let me go here. I will give again a show running config, and here we can see they set these 3 IPv6 route with the exit interface. That's fine. And here we can see exit interface they given is serial 000. I think it's correct. Yeah, serial 000. It's correct. So we have to see the network address, IPv6 network address. We'll keep it here. And here we can see 2001 db8 345. Okay, it's easy to remember. So here we can see LAN 2 2001 db8 3:/64. It's correct. Then here we have a 4:/64. This is also correct. Then here in LAN 3 we have 2001 db8 5:64. Yeah, it's correct. There is no problem with IPv6 static route. Next we will go to this router R2. Enable show IP route. Let me try this. And here for this R2 has two remote networks, LAN 1 and LAN 2. Here we can see they configured two static routes, 31.10, 31.1.128. So here we can see LAN 1 and LAN 3. Here we can see the given network address and this prefix are perfect. 172.31.1.0, 172.31.1.128/26. We have to verify this next hop address what they given. It's for 1.0 they given 1.198. 1.0 means which is towards LAN 1, and obviously the next hop address will be the IP address of this interface, serial 000 in this router R1. Coming to our addressing table, we will verify its address R1 serial 000. Here we can see it's 1.194, but here they given 1.198. It's incorrect, right? Yeah, so we have to change this. Then coming to the second one, this is correct. We have to verify this next hop address, and here we can see LAN 3. So here the next hop address will be the IP address of this interface, serial 001 in this router R3. So R3 serial 001. Here we can see it's 198. Oh, just they swapped and given the address. It should be 198 here, and it should be 194 here. Actually, they interchange the next hop address. So we identified a problem in R2 also. We will correct it. First of all, we have to remove this configuration, then we will add it correctly. I'll give a show running config so that we can copy and paste that command. Here we can see that. Okay, so just I will copy the first command, then we will remove it. No, then paste that. It's removed. Oh, sorry, we have to go to global configuration mode. Conft, then no. Give that command. Again, give no. We will copy the second line here. Both they configured incorrectly, means they interchanged its next hop address, right? Now we will configure it correctly. Just I will copy this first line, and here we can edit this 172.31.1.194. It should be 194. Okay, then for the second one it's 198. Instead of 194 it's 198. Okay, that's fine. We can verify it. Show IP route, and we can see 1.0 via 172.31.1.194. It's correct. The IP address of this interface serials 000. Then via 1.128 via 172.31.1.198, the IP address of this interface serial 001. Now it's correct. Okay. Also, we will verify IPv6. Show IPv6 route, and here we can see those static routes they configured. Let me see this LAN 1 IPv6 address 2001:db8:1:/64. Then LAN 3 2001:db8:5:/64. Again, coming back to our output, here we can see static route for LAN 1 2001:db8. Oh, here we can see the given 6. It's not 6, it's a db8. So they configured incorrectly. This network they given incorrectly, right? 2001:db6, it should be db8:1:/64. Via this next hop address, we will verify this next hop address also. The IPv6 address of this interface serial 000 in this router R1. Here we can see that 194. Okay, I will come back and I will verify it. Here we can see 2001:db8:2:194. It's correct. So we have to change this network address here. Okay. Next we will go to static route 2001:db8:5:/64. It's correct. We have to verify its next hop address what they given. The IP address of this interface serial 001 in this R3. Here we can see IPv6 address. We will verify with this 2001:db8:4:198. It's correct. There is no problem with this. So we have to reconfigure this static route. So we identified IPv6 static route problem also in this router R2. So just I will give a show command again, show running config, and we identified the problem here, db6. Okay, just I will copy this command. We will remove it. Conft no, then paste that command here. Then we will correct it. We will change this db6 to db8. IPv6 route db8. Yeah, it's correct. This is a solution. Next we will go to this router R3. Enable show IP route. We can see 3 static route. They configured with the exit interface. This is also configured with exit interface, and this is also configured with the exit interface. Coming to our topology, here we can see 3 remote networks for this router R3. LAN 2, LAN 1, LAN 2, then this serial link, this WAN link. First of all, we will verify this LAN 2 172.31.00/24 with the exit interface serial 001. I will go to R3. 172.31.0.0. Here we can see 172.31.0.0/24. It's correct. Is directly connected to serial 001. Yeah, this is correct. Next remote network is 172.31.1.192/30 with exit interface serial 001. Coming to R3, and here we can see 172.31.1.192/30 is directly connected to serial 001. Yeah, this is also correct. Then coming to this LAN 172.31.1.0/25 with exit interface serial 001. 1.0 1.0. Yeah, here we can see static root 172.31.1.0. It's correct, and /28. I think they given /25. Yeah, they configured incorrectly, so we have to correct it here. This prefix or this submit mask they configured incorrectly. We have to correct this. Is directly connected to serial 001. Okay, this is fine, but we have to remove this static root and we have to correct it. Sure, I will give a show running config so that we can copy that command. Yeah, here we can see IP root 172.31.1.0, and here they given a 240 instead of /25, that is 128, right? Yes, so we have to correct it. Just I will copy this command because we have to remove it. Conft we will give no, then give that address, I mean that command, then we will correct it. Copy again and paste here, then correct that submit to mask 255.255.255.128 because they given the prefix as a /25, right? And here one is missing. Okay, let me verify it. Show IP root, and now we can see this 172.31.1.0/25 is directly connected to serial 001. See, here we identified the problems and then we resolved it that time itself. Okay, so we can fill all these problems here and also we can write the solution whatever we given here. And even we are going through this step 2 also, repair the problems, configure the devices so that full connectivity exists between the host on the LANs over IPv4 and IPv6. Also, they given a note here. Your task is to establish connectivity using the existing static route design. Changing the types of static routes used will be result in a loss of points. Okay, that's fine because we have to identify the problem, then we have to resolve it. Coming back to R3 again, so we done for IPv4. Next we will verify IPv6. Show IPv6 route. And here we can see static routes, and here we can see only two static route IPv6 static routes because previously I have shown R3 got 3 remote networks, I mean unknown networks, that is LAN 1, LAN 2, and this WAN link, right? So but in this IPv6 routing table we can see only two static routes. That means one is missing. We have to identify it. Also we have to check this configuration also, these two static route configuration also. We will verify this IPv6 static route. First of all we'll verify this 2001 db8 2:/64 via serial 0001. Okay, this exit interface is correct. We have to verify this IPv6 address 2 double colon. Okay, fine. Here we can see 2 double colon this WAN link. Okay, that's fine, it's correct. Also we can see 2001 colon GB8 colon 3 double colon slash 64. This is for LAN 2. Yeah, this is also correct. That means they did not configure a LAN 1. I mean, they did not configure this IPv6 static route for this LAN 1. And here we can see its IPv6 address 2001 colon GB8 colon 1 double colon slash 64 using its exit interface serial 001. We will configure it. So this is the problem we identified again in R3. Here I will give a show running config. Okay. And here we can see IPv6 route they configured. Now we have to configure. I will copy this command. I will copy this line because we have to change only this hexstat. IPv6 route 2001 colon GB8 colon. It's instead of 3, it's 1 double colon slash 64. Here you can see that 1 double colon slash 64. Yeah, it's correct. Then exit interface serial 001. Then press enter. We can verify it. Give exit. Show IPv6 route. Now we can see these 3 unknown networks added here. R3 is aware of all these remote networks. So just now we added this IPv6 static route 2001 colon GB8 colon 1 double colon slash 64 via serial 001. We can test the connectivity. Let me try to add this symbol PDU. Yes. So I will send from this PC1 to PC2. We'll try once more from PC2 to this PC1. Okay, it's successful. So IPv4 is working. We'll go to PC to this server. Once more we'll try from PC2 to this server. It's successful. From server to PC1. Successful. Now we will ping using IPv6 address. We'll go to PC2 and we'll copy its IPv6 address. We can ping from PC1. Perfect. We will go to server, then we will ping to PC2 using its IPv6 address. Perfect. I will get the IP address of the IPv6 address of this server. Then I will test from PC1. Yeah, it's working. Okay, that's all in this activity. That is a troubleshoot static and default routes. Here we can see our completion status. It shows 100%. Now dear friends, if you have any doubt, any suggestions regarding this PyTracer activity, please comment below. And you can contact our team for any technical support. Link you will get from the description below. Stay tuned and we will meet again with the next video. Thank you.